Thank you. Oh, okay. So I'm just using this tool for the first time, so sorry if I'm not using it properly. So as I was already introduced, my name is Alisa. I'm a software engineer at Preply. I'm not a SRE, but we're still doing some SRE job in any team anyways. So my talk will be not that serious as the previous one, so you can just relax. And I will talk about some sides of the observability which can make you feel like it is not what it seems. Okay, cool. Sometimes some mysterious things may happen, not only in the woods, but on your screens in your daily routine. And so everyone probably read a lot of time these words from any instructions on how to configure this or that tool, that it just takes a couple of easy steps. So we always trust these words. So if we talk about observability, so these are couple of examples of how we do configure it in our services. So you can see that the configuration, so this is like almost the identical what we do run really in our production, just very, very few lines of code, just omitted for brevity. So you can see that it really is simple. Like you pass a couple of options, just taking them from the environment variables, and this is basically it. So yeah, we have a couple of assumptions that the observability tools, like many others, they just work without any specific additional magic, let's say, just like it described in the documentation, and like this is it. And like, yeah, you set everything up following the documentation, and you shouldn't do anything apart from that. But actually, in reality, sometimes you might face really weird, obscure things that you do not expect. And what's worse here is that very often it happens, so you face those things in critical situations, like during incidents or during some presentation, as a Meetup, for example. And so I will tell a few stories of how we tackled a couple of such things. So this is not something about like very clever solutions or rocket science. It's rather some crunchy stuff, how we applied this to handle like problems, very surprising problems that should have never happened in the first place at all. But yeah, just don't take it very serious, as I mentioned in the beginning. It's more like funny story. So the first one is how we politely forced traces to respect our errors. It is a story about one of our core front-end services, which serves SEO-friendly pages, and it is built in React, Next.js, and Node.js. But before that, I want to align on a couple of terms. So I will be using terms trace and spawn quite a lot. So if you just don't know what does it mean, and so trace, it just thing that depicts the request execution path in the distributed system, and it consists of one or multiple spans, and the span itself is just a small unit of work during this request execution path. All right. So this is how it typically looks in theory, and this is how it looks in Datadog, the tool we use, as the previous speaker mentioned. So you can see those spans of a single trace. So they form this flame graph. So yeah, the story starts with the very typical situation every on-call engineer face in their daily work. So you receive an alert, and that some error spike happens, and you just go to the tool, to Datadog, to check. And okay, so what does it say? Just like it says that the error true. Okay, we trust this, but we already know that the error is true, but we need some more information about the error, okay? So, okay, let's check. So yeah, how we typically debugged some problems on production when we lived with this not informal stuff, informative stuff. So we can go through all the spans and try to find some span which comes from some backend service. Sometimes they contain more information about the error. Or one could go to the APM of that backend service directly, because it might be more convenient just to check some error spikes there as well. Or just use some other tool like Sentry or Kibana and try just to map this like logs or errors to your concrete incident. So if we go to the documentation, the official documentation, it says that for a trace to be properly error tracked, its entry span, root span as it's called also, must contain some information, must contain some tag. So yeah, these tags that must be set to the root span, and it will be tracked correctly. So returning to this, we can clearly see that something is wrong here with setting those tags. So we decided. So we found out that it was a bug in the library we used, and later it was fixed, but we were unable to upgrade to that version because we currently run a very ancient one, and well, it's another story like for another SRE meetup, because it's involved a couple of incidents as well. So yeah, we decided to craft our own solution and just to make manually what it should have done for us automatically. So it's as easy as this. So they want us to set specific tags, and we just do this. Pretty easy. Okay, and it fixed our problem. We just can see here that error contains some details. Something failed, even some stack trace. It's pretty good, really, at this point. But we missed a couple of important pieces here. We actually caused another incident by this change because we got spike of four errors, and well, actually, four errors are quite fine for us, So we have a lot of SEO pages that might be removed; they come and go. And but they still might be cached by Google, or some bots might be trying to access them, and it's okay to have 4 errors. But before that change, they were not treated as errors, and they were just okay requests. So yeah, this was really quite unpleasant experience, because a couple of teams were paged with alerts, and really people were nervous, because everybody was just thinking that some attackers started doing something wrong with our website. So okay, we made another approach, a bit more wiser. We decided not to attach those details to the error tags themselves, but for such 400 errors, but attach those details to a separate tag. So yeah, it fixed this issue. This spike has gone. Everything went back to normal. But now we lost the details information, so we ended up with almost what we started with. So you can still find this error details information here, but look up. Okay, yeah. So look, this is the information tab, and it should be here in this place. And really, people rarely go to the information tab when they're looking for error details. It's it's not obvious. And error details are missing. So the third approach was even more wiser, I think. So we decided to create an artificial spawn instead, just child to our entry spawn, and attach this information there. So it would keep the traces, for such 400 errors, of course. This would keep the traces as okay, and no error spike would be recorded. At the same time, we will keep this error details in a proper place. Okay. So this is how it's implemented. Just quite simple code. Just we create spawn, add details to it, and finish it. And yeah, this is how it looks in the Datadog. So on the left, you can see this tiny one, client error. It's named. And on the right, you can see error details just right in place. Just to wrap everything up, on the left is how it now looks in the end for 500 errors, and on the right is how it looks for 400 errors. Just make the note of this. So those are errors, those are green, those are not, but they still contain this information. Okay. So this wraps up the first story. Everything is good. Everyone is happy. It was, of course, it was not ideal solution, because it doesn't seem like pretty obvious why we are doing these things. But maybe later we will successfully upgrade to the latest version of the library, and it will go away automatically. Okay. Okay, the next one is a bit shorter. It is about how we impolitely first traces to respect our errors. Okay, there is a misprint, not requests here, but no, this is fine. Okay, so it is based on our backend service, which is built with the Python, Flask, and GraphQL. Okay. Again, before I start diving into this, just a refresher on what GraphQL is, because it's important. So GraphQL is it's a query language and runtime for executing such queries. using the type system you define. Okay, and it uses HTTP. Yeah, unlike REST, where different type of HTTP methods are used for different operations like put, get, and so on. REST typically uses POST for everything, for querying data and for mutating it. And like the base concept of it, unlike resources in REST, is the entity graph. And entities, they are not defined by URLs, okay? The GraphQL server, it runs on single entry points, and all the requests go to single entry points. Typically, it's called /GraphQL, but okay. So what was the problem? So how it started? We suddenly started receiving alerts from an old monitor that monitors some like slow requests which take more than 1 minute. And yeah, we went, as usually, we went to our Datadog to see who is that slow. And yeah, given that we have only single entry point, and the tracer, it like maps resources to URLs, okay? So we have single URL, we have single resource. We cannot distinguish between them. So one just should have go through all the traces, just open the details and try to find out which query is that slow. But imagine you have multiple such queries. So how do you make sure that you found the complete set of them? So we need to definitely to find a way how to form some unique resource name. And what we do, we just craft some resource name string using the information about GraphQL operation and assign it to spawn a resource name to override this. And it basically what we did in the first place in this service, and it was working. And it is set up in similar fashion in other, I mean this previous one, in other services, and it's fine there. But after an upgrade of library we use, so upgrade of libraries very often, like very funny story, it broke. And yeah, it broke specifically for Flask applications because maintainers of the library, for some reason, decided to force setting the span resource name to Flask application URL rules. And in our case, it was GraphQL rule. So like the fix is just 2 lines. We checked the URL of the span and set this custom resource name which we crafted here. Okay. So yeah, and it fixed our problem, and yeah, it just now you can see that there are different operations. You can clearly see who is slow, who is not. Okay, to wrap everything up, just a couple of takeaways. First, like, do not rely probably to on third-party tools. I mean, complex third-party tools, maybe even not complex, but complex especially to work out of the box. Sometimes you need to make additional configuration, which is even not described in the documentation. So you need to dig deeper because something might be very specific to your service, which is not supported by the tool. even if it works now, it might broke tomorrow. Like, you can upgrade library version. You can change something in your application code or in your instrumentation code, whatever. Just keep an eye on it. So try to keep it single, not simple. Those like entities contradict somehow. So it's more convenient if you can find all the required details of an issue in a single place. So for us, it's Datadog. We use it heavily, and it takes much more time to look for some details in other tool, and you need just to mitigate an incident as fast as possible. And yeah, the last one would be just trust your tools you use, of course, because if you don't trust tools you use, like why do you use them at all? But still be suspicious about what they're telling you, because like sometimes it might happen that it's like not the system you observe misbehaves, okay, but the tool misobserves. Like it was in our case of for errors. Like we were sure that something is going on with our application, while it was going on with the tracing tool. Okay, this is it. Thank you for attention, and ready for your questions.